Hi! Today I will explain how to extract features from perClass Mira. We have a dataset made of potatoes plants. Some of them are healthy and some of them are infected. We labeled objects for defining the background, the plants and the label. Once the classifier is built, we can detect the background from the plants. In our case, we want to make sure that we have only one object per scan for extracting features. In the Object panel, we define the minimum size of object as 5000 pixels per object. In the Visualization panel, we select the equation for defining a spectral feature. Here, we compute a ratio of two ranges of bands. We can define the size of each range and change the color map for the visualization output. We can see that around 680 nanometers there is an absorption band due to the chlorophyll. The objective is to obtain a high contrasted image, which means a large range of output values. We can rename the spectral features by right-clicking. So here the ratio between bands are around 750 nanometers and 680 nanometers. Instead of defining visually the spectral indices, we can also define the equation regarding their wavelengths as parameters. For example, in this case we use NDVI spectral index defined by that. The autoscale disenabled allows us to compare each scans with the same color map scale. When we apply this visualization to scans, we clearly highlight the differences between healthy plants and infected plants for both indices. In the Mira version 3.0, a new functionality for extracting features has been created. In this case, we can extract features for each object pixels computed by object segmentation. We selected the spectral features histogram for both spectral indices defined previously. Once we select them all, we can export these features to an Excel file. In this file, we have for each scan one object and their spectral index distributions. This normalized histogram is divided into 20 bins. Finally, we can visually highlight differences between healthy and infected plants by plotting their spectral indices distributions. We clearly see a peak in this histogram due to the virus. Thank you for your attention.